No, ma'am.
Good afternoon, everybody. So in the previous class, we were discussing about difference equation, how to solve the difference equation using forms we have discussed in the previous in today's class. So this is for your practice. You all can simultaneously work out along with me. So you will be clear with the topic of how to solve the difference equation. Ultimately, we are finding the solution of the difference equation as we have found the solution of any kind of differential equations. So this is a difference equation and we are finding the solution of that using the concept of Z transforms. So today's question, we'll discuss the first one. Solve by using Z transforms. We need to solve by using Z transforms. The question is yn plus 2 times yn plus 1 plus yn equal to n. With certain conditions, they are given to be y0 equal to 0 and y1 is also equal to 0. So you can work out along with me. First thing, what do you need to do over here when the difference equation is given? What do we need to do? What do we do first? Here is the difference equation. We apply Z transform on both sides. Apply Z transforms on both sides. What do we get when we apply Z transforms on both sides? We will have Z transform of yn plus 2 plus 2 times Z transform of yn plus 1 plus Z transform of yn, that is equal to Z transform of n. Am I correct? Is it okay, everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Then you are supposed to remember these formulae, that is Z transform of yn plus 2. What is Z transform of yn plus 2? It is Z square into y bar of Z minus y0 minus y1 into Z power minus 1. Then we have Z transform of yn plus 1. Z transform of yn plus 1 is Z into y bar of Z minus y0. Then we know Z transform of yn is y bar of Z. So these things we need to remember and let's substitute in the equation 1. So from 1, when we substitute all these things in equation 1, what do we get? Z transform of yn plus 2 is Z square into y bar of Z minus y0 minus y1 into Z power minus 1. This is Z transform of yn plus 2 plus 2 times Z transform of yn plus 1. What is Z transform of yn plus 1? It is Z into y bar of Z minus y0. This is Z transform of yn plus 1. Plus third term is Z transform of yn. What is Z transform of yn? It is y bar of Z. That is equal to Z transform of n. What is Z transform of n? Anybody remember? Z transform of n. I have given these standard Z transforms in the first class where we started Z transforms. What is Z transform of n?
Z by Z minus 1 whole square, ma'am.
Yes, Z divided by Z minus 1 whole square. You need to remember all these things. So if anybody do not remember, please go back and check that notes. I have listed those standard Z transforms over there. In the next step, what we do is we collect all the coefficients of y bar of z. So coefficient of y bar of z, what is y bar of z coefficient? Y bar of z coefficient here, first step we have z square. In the second expression, it is y bar of z into 2z. So we will have plus 2z. Then here it is coefficient of y bar of z is 1. So we have z square plus 2z plus 1. That then what else is remaining, and we are given the initial conditions, both y0 and y1 values are 0. So y0 is 0, y1 is 0. Here y0 is 0. So rest all terms will be 0. So we get z divided by z minus 1 whole square. Now how you can write this as z square plus 2z plus 1. What is this? What is z square plus 2z plus 1?
Z plus 1 whole square, ma'am.
Yes, z plus 1 whole square, a plus b the whole square, a square plus b square plus 2ab. So here it is z plus 1 the whole square. This one you can write it as z plus 1 whole square. This implies what is y bar of z? Write the expression for y bar of z. You can take this to the other side. It will go to the denominator. So y bar of z will be z divided by z minus 1 whole square, which is already there. And this we need to take to the other side. So it comes here in the denominator. It will be z plus 1 the whole square. Am I correct?
Yes, ma'am.
Okay, next what shall we do? We need to solve this. See the denominator. It is the product of linear factors we have. So this can be easily solved by using the method of partial fractions, which we have been discussing since I think 4 to 5 classes we have been discussing how to solve it using the method of partial fractions. So we shall first step what we have to do. When we have y bar of z, first step what we need to do is we need to find what is y bar of z divided by z. That is divide by z on both sides. So what do we get when we divide by z on both sides? Here if we divide by z, it will be y bar of z. So here also when you divide by z, this z and this z get cancelled. So what remains? 1 divided by z minus 1 the whole square into z plus 1 the whole square. This is after we divide by z on both sides. Now how do you split this? You have square term to both the terms. There are two terms, product of two terms, and the power is square. So this can be written it as a divided by z minus 1 plus b divided by z minus 1 the whole square plus c divided by z plus 1 plus d divided by z plus 1 the whole square. This is how you do it. Is it okay, everyone? Is it okay? This is how
Yes,
you
ma'am.
split it. Those who have not learned properly in PUC these method of partial fractions, this is going to be little difficult. When you have the linear factors, product of linear factor, if it is simply z minus 1 into z plus 1, then it will be a by z plus 1 plus b by z plus 2 or z plus 1 or z minus 1 whatever. But when we have a power over here z minus 1 whole square, you should split into two terms. First one is a by z minus 1 plus b divided by z minus 1 the whole square. Similarly for z plus 1 whole square, it will be c divided by z plus 1 plus d divided by z plus 1 the whole square. Okay, this is how you split it. This is actually the method of partial fractions. This is not something different. Is it okay? Anybody is finding it difficult? Please tell me. You can ask me, you can contact me later on so that I can explain you all. But do not keep that pending. This is very easy. When you have a product of linear factors, and the powers. So suppose if you have cube over there, you need to add one more term, that is e divided by z plus 1 whole cube. Suppose if you have a cube term over here. That is what I mean to say. How much ever terms are there, that many terms you need to add. What is the next step over here? We have to multiply the entire expression by this denominator. What do we do? Multiply by z minus 1 the whole square into z plus 1 the whole square to this entire expression. To this entire expression, if you multiply by this term, here when you multiply the denominator and numerator get cancels, 1 remains. When you multiply over here, say z minus 1, one of the z minus 1 get cancels. So what remains? Z minus 1 into z plus 1 the whole square plus b into, when you multiply over here the entire term, denominator z minus 1 whole square is there. So the entire term get cancels, z plus 1 whole square remains. Similarly, when you multiply over here, only one z plus 1 get cancels. So what remains? C into z minus 1 whole square into z plus 1 remains. Plus to the last term, when you multiply over here, z plus 1 whole square, all those things get cancels. Only z minus 1 whole square remains. Is it okay, everybody? Is it okay?
Yes, ma'am.
Prashant, is it okay? Prashant, Prajwal, Kavita, is it okay?
Yes, ma'am. Yes, ma'am.
Okay. Now next, what shall we do? Now we need to find the constants A, B, C and D. How do we find those constants? What do we do first?
Ma'am, put z equals to 1.
Value of Okay, we shall put first z equal to 1. Let's check what we get when z equal to 1. So we put z equal to 1 over here. See, coefficient of A will be 0 because 1 is 0. Next here B will remain C. C also will become 0. When you put 1, z as 1, 1 minus 1 is 0. Similarly, here D will become 0 if you put z equal to 1. 1 minus 1 is 0. So check now. So when you put z equal to 1, left hand side we have 1. A will be 0 because here 1 minus 1 which will be 0. We get B value here. B into Z is 1. 1 plus 1 the whole square. Here this also will become 0 and this also will become 0 if you put Z equal to 1. So we get the value of B. What is B? 1 plus 1 the whole square, 2 square, that is 4. So what is the value of B? It is 1 divided by 4. Next we shall put z equal to minus 1. Put z equal to minus 1. What happens? Left hand side 1 remains as it is. If you put z equal to minus 1 over here, it is minus 1 plus 1, it will be 0. That's why coefficient of A will be 0. Come here to the second term, that is B. B into Z plus 1. If I put Z as minus 1, again coefficient of B also will be 0. Next, check the third term, that is C into Z minus 1 whole square into Z plus 1 is there. So if you put Z equal to minus 1, it is minus 1 plus 1 which will be 0. So coefficient of C also will be 0. Check for the coefficient of D. We will get the value of D over here. So Z is minus 1 minus 1 whole square. Minus 1 is minus 2. Minus 2 whole square will be 4 itself plus 4. It will be 1 equal to D into minus 2 whole square. Minus 2 whole square is plus 4. So value of D will be 1 divided by 4. Is it okay? Anybody wants me to ask anything? Anybody has any doubt? Okay, if no doubt, we'll continue. Next, what we do here is, see, just look into the expression. Look at this expression. We'll take this as star. This is going to be a equation of power what? What will be the highest power of the variable in this expression? Just tell me.
2, ma'am.
Is it? Check once again.
3, ma'am. Cube.
Yes, it is 3. So what we do is it's going to be a equation or a polynomial whose highest power is 3, because you can see over here this is z plus 1 the whole square and z minus 1. So a plus b whole square, you will have a term z square. When you multiply this z square with z, it will be z cube. So this equation, or this is a polynomial whose highest power will be 3. Okay, in order to find the remaining constants, we have found B and D only. We need to find A and C. These two constants we are yet to find. So what we do is, as the highest power is cube 3 over here, we shall equate the coefficient of z cube. Equating the coefficient of z cube. Check what you get. Equating the coefficient of z cube. So here on the left hand side there is no coefficient of z cube, so it will be is equal to, here we get, here it is a plus b the whole square, so z square into z, and the coefficient will be a, so coefficient of z cube will be a. Here in the term b we will not get any z cube term because it is a plus b the whole square, so highest power will be 2 only. Next, when you take this, when you multiply these two terms, it is z minus 1 whole square into z plus 1. So when you expand this, you will get z square, and there is z term over here. So z square into z will be z cube. So coefficient of that will be c. So it will be c. And here also we will not get any cubic term. It will be a minus b whole square. So maximum power will be 2. So when we equate the coefficient of z cube, we get 0 equal to a plus c. Am I correct?
Yes,
Or
ma'am.
c value will be what? Minus e. Or c value will be minus e. Anybody wants me to repeat this? Anybody wants me to repeat this? We have just equated the coefficient of z cube on both sides. On the left hand side there is no z cube term, that's why it is 0. Then on the here a and c we have z cube term we will have in that expression, that's why the coefficient of z cube will be a and c. So it is a plus c. So a plus c equal to 0, that's why we get c equal to minus e. Next step what we do is we shall put z equal to 0 on the in the entire expression, that is star. If you put z equal to 0, what do we get? Left hand side remains as it is, 1 equal to, if you put z equal to 0, so 0 minus 1 is minus 1 and here we get minus a. Am I correct? You put z equal to 0, 0 minus 1 is minus 1, here it is 1. So minus 1 into a, it is minus a. And the second expression, if you put z equal to 0 over here, 0 plus 1 is 1, 1 into b will be b. Put z equal to 0, 0 minus 1, that is minus 1, minus 1 whole square is 1, 0 plus 1 is 1 into c will be c. Then here z is 0, 0 minus 1 whole square will be plus 1, so we will get d. Just check whether it is correct. I have put z equal to 0 in the entire expression star. Srishti, is it okay? Srishti, Sushmita, Mohammad Hussain, Manikya, is it okay?
Yes, ma'am.
Yes, ma'am.
Okay. So now you check. Now what we do is we know the value of b and c, correct? Just see this expression. See this one. We know the value of b, we know the value of b, and we know c equal to minus a. Am I correct? Substitute these things over here. Minus a can be written it as c, so you write it as c. What is b value? It is 1 by 4. What is c? Keep it as it is. What is d? 1 by 4. Simplify this and tell me the value of c. Be quick.
One by 4.
Anybody, any other answer? Anybody else, any other answer? What is the value of c? Here, what do we get when we simplify this? 1 equal to c plus c. It will be 2c. 1 by 4 plus 1 by 4 will be 2 by 4. 2 by 4 is 1 by 2. So what do we get from this over here? 1 minus half will be half. So c will be 1 by 4. C will be 1 by 4. So what is the value of e then? To minus a, c to be value of a. Chaitranjali, what is the value of a?
Ma'am.
What? What is the value of a? Rohini, what is the value of a? Prajwal, Rohini, Shilpa, what is the value of a?
Minus 1 by 4, ma'am.
Minus 1 by 4. See, just see this expression. C value is minus a. C I have got it to be 1 by 4, which is equal to minus a. So a value will be minus 1 by 4. A value is minus 1 by 4. Now substitute all a, b, c, d in this expression. We'll take this as equation 2, substitute the value of A, B, C and D over here. So what we will get over here, y bar of z divided by z, that is equal to, we will have a by z minus 1. A value is minus 1 by 4. Minus 1 by 4 into 1 by z minus 1. Second step, b by z minus 1 the whole square. B divided by, b is what? 1 by 4. So it will be 1 by 4 into 1 by z minus 1 the whole square. Next, c divided by z plus 1. C value is 1 by 4. 1 by 4 into 1 by z plus 1 plus d. D will be 1 by 4 into 1 by z plus 1 the whole square. What we have done, we have substituted the value of a, b and c and d in this equation 2. That is what? It is y bar of z divided by z. But what we want y bar of z. So what we do, we multiply by this z to the entire expression. This entire expression you multiply by z. We will get y bar of z. So it will be what? Minus 1 by 4 into z by z minus 1 plus 1 by 4 into z by z minus 1 whole square plus 1 by 4 into z by z plus 1 plus 1 by 4 into z by z plus 1 the whole square. This is what? This is y bar of z. Next what we do is, you can see over here 1 by 4, we want yn, the solution. In order to get the solution, we apply inverse inverse z transform, that is z inverse of y bar of z. We apply inverse z transform on both sides, and 1 by 4 is the common term in all the 4 expression. Let me take that outside and then apply the inverse z transform. So it will be inverse z transform. There is a negative sign, so minus inverse z transform of z by z minus 1. Then plus inverse z transform of z by z minus 1 whole square. Then plus inverse z transform of z divided by, whenever plus is there we will split it as z minus of minus 1, because we have the formula for inverse z transform of z by z minus k, but not for z by z plus k. That's why z plus 1 we will split it at z minus of minus 1 plus inverse z transform of z divided by z minus of minus 1 whole square. Wherever plus is there, you need to split this as minus of minus. Always remember that. So this is nothing but 1 by 4 into minus. What is inverse z transform of z by z minus 1? Remember this formula. Inverse z transform of z by z minus k is k power n. Remember this. So what will be inverse z transform of z by z minus 1?
1, ma'am.
1 power n.
1 power n is 1. Do not write 1 power n, because 1 power anything is 1 itself. That's why inverse z transform of z by z minus 1 is 1. Then second term, what is the inverse z transform of z by z minus 1 whole square? Power is there. For that you have a different formula. What is the formula? Inverse z transform of z by z minus 1 whole square is what? Anybody remember what is it?
Ma'am, k power n is n, ma'am.
That when if you have a k, but here k is 1, so it will be what?
It is n, ma'am.
It is n. When you have k, you tell me that formula. But here we have the standard formula. Inverse z transform of z by z minus 1 whole square. It is n. So inverse z transform of z by z minus 1 whole square is n. Next, this one, third term. Inverse z transform of z by z minus k. In place of k we have minus 1. So this will be what? What is the inverse z transform of this?
Ma'am, minus 1 power n.
Minus 1 power n. See, always remember inverse z transform of z by z minus k is k power n. So inverse z transform of z by z minus 1. K is minus 1. That's why it is K is minus 1. That's why we have taken it as minus 1 power n. What about the last term?
Minus 1 power n into n, ma'am.
Are you sure? Think about that last fourth term.
I mean, we have to divide and multiply by minus 1 on both sides, on numerator and denominator.
Very good. Very good. So just see over here, there is a difference. You need to think on it a little bit. So I would like to explain separately over here. Inverse Z transform of Z by Z plus 1 it was plus 1 whole square. So I have written it as minus of minus 1 whole square. Okay, this is Z plus 1. We have over here Z plus 1, Z by Z plus 1, but we do not have the formula for plus term. That's why we split this as Z minus of minus 1 whole square. And there is a formula, see over there are standard Z transforms. According to that, inverse Z transform of Z by Z minus 1 whole square is what? It is n, directly n. These are standard things you need to remember. But suppose if you have inverse Z transform of kz divided by z minus k whole square, then it is k power n into n. Then it is what? K power n into n. The same concept applies over here also. If the k is directly 1, you write directly n, as I have written over here in the second step. Inverse Z transform of z by z minus 1 whole square is n. It is done. But in the fourth step, k is not 1, it is minus 1. So in that case, you need to apply the second formula. K is minus 1. If k is any number other than 1, then you have to go for the second formula, that is kz by z minus k whole square. So k is what over here in this case? It is minus 1. In the numerator also we should have k term in order to apply this formula. But in the numerator we do not have that k. So what we do? We write that as minus 1 divided by minus 1 into z divided by z minus of minus 1 whole square, so that we can apply this formula. You just need to think about this. Minus 1 is a number which is not equal to 1, which is different from 1. That's why we have to apply this formula, inverse Z transform of kz divided by z minus k whole square, which is k power n into n. But k is not there here in the numerator. That's why what we do? We write that as minus 1 z, and when you have multiplied minus 1, you have to divide by minus 1. So I'll write that minus term outside. Minus 1 into z divided by z minus of minus 1 whole square. Now this is of the form inverse Z transform of kz divided by z minus k whole square, which is what? K power n into n, where k is what? Minus 1 power n into n. Is it okay, everyone? Tell me if you have any confusion in this. Anybody, any confusion? Only the difference is k is not equal to 1. If it is minus 1, that's why you have to use the formula inverse Z transform of kz by z minus k whole square, where k is minus 1. So k was not here. If you had already minus z, then you can directly apply that formula. But minus 1 was not in the numerator. That's why we have multiplied and divided by minus 1. That's why y. So the solution of thing. Prashant, are they able to understand? Yes or no? Rohit,
Ma'am.
Parvati, is it okay?
Yes, ma'am.
Yes, ma'am.
Okay. So I hope this is clear. We'll discuss one more question. Work out along with me so that it will be easier for you all to do the remaining problems. So we solve the difference equation, very simple one. I'll give you yn plus 2 minus yn plus 1 minus 2 times yn equal to 0. Yn plus 2 minus yn plus 1 minus 2 times yn equal to 0. We have to solve this using Z transforms. Will you all do this? Just work out along with me. When an equation is given, first what you have to do? You have to apply Z transform of yn plus 2 minus Z transform of yn plus 1. You need to apply Z transform everywhere. 2 times Z transform of yn. That is equal to Z transform of 0. Okay, whenever a question is given, first thing what you need to do is you have to apply Z transform on the entire equation. So when you apply Z transform on the entire equation, we know Z transform of yn plus 2. What is Z transform of yn plus 2? It is Z square into y bar of Z minus y naught minus y1 into Z power minus 1 minus what is Z transform of yn plus 1? It is Z into y bar of Z minus transform of yn, it is equal. What is Z transform? Z transform is 0. Next we do each of y bar of Z. And the coefficient of y bar here Z square, and here is Z. Then here we get minus 2. This is what we get. Then what else is remaining now? List out. Here we have Z square into y naught minus Z square into y naught, then minus y1 into Z power minus 1 into Z square. Z power minus 1 into Z square will be Z. Then here minus in y naught into plus y naught, it will be minus of minus will be plus y naught, that is equal to 0. This is what we get. Now tell me, what shall we do next? What shall we do next? Anybody? What do we do? So what we are supposed to do?
I'm taking y naught as common.
And minus here one side line square minus equal to 0. Y naught minus Z square into y naught. So if I take y naught outside, 1 minus Z square will remain minus y1 into Z. Next intention is we want y bar of Z. So y bar of Z into Z square minus Z minus 2. You take this to the other side. What do we get? When we take this to the other side, it will be y1 into Z minus y naught into 1 minus Z square. This is what we get. Y1 into Z minus y naught into 1 minus Z square. Next, we get what we have to find. What is y bar of Z? You divide the entire expression by this. So what do we get? Y1 into Z by Z square minus Z minus 2. Then minus y naught into 1 minus Z square divided by Z square minus Z minus 2. What do we do next? What do we do next? Just check whether we can simplify this z square minus z minus 2. Can we simplify this? Minus 2 can be written as minus 2 plus 1. Correct? Minus 2 into plus 1. Hope you all know how to find the roots. Minus 2 is a multiple of minus 2 into plus 1. Minus 2 plus 1 is minus z. So I can split this as z square minus 2z plus z minus 2. Do we get the same equation? Z square minus 2z plus z is minus z minus 2. So if z is common, z minus 2, and here it will be plus into z minus 2. Am I correct? Z minus 2 into z plus 1. Is it correct? Can I split it? Z square
Yes,
minus
ma'am.
z minus 2 as z square minus z minus 2 can be split and written it as z minus 2 into z plus 1. Next, what shall we do?
Taking P and Q, ma'am.
Can do that. Can make as so in the next step 1 z equal to z by so z square minus 2 can be done as z minus 2 into z plus 1. Talking about this, if I take minus sign outside, okay, minus sign outside, I can z square correct. And square is minus of this minus will become plus minus z square will be divided by z minus 2 into z plus 1. My intention is to remove that z. Is it possible? Z square minus 1. Can I write it as z minus 1 into z plus 1? Can we write? Can we write?
Yes, ma'am.
Okay. So when we write like that, what happens? One term in the denominator get cancels. Let's check whether we can do it. Y1 into z by z minus 2 into z plus 1. Whether keeping it like that only is better or simplifying is better. When if we cancel out z minus 1 by z minus 2 remains in the denominator. Okay, you can do it in both way. You can try. We will keep this as it is. Okay, we will keep this as it is. Let's keep this as it is. You can try after the class by cancelling the terms. What happens? Z square minus 1 into z minus 2 into z plus 1. We'll keep it as it is, but you can try. If we cancel out z plus 1 from the numerator and denominator, what's going to happen? That's what you can do. So we'll take this as P of z and we'll take this as Q of z. You can try afterwards by cancelling z plus 1. So we'll check whether we get the same answer. Now, we'll take P of z. What is P of z? P of z equal to z by z minus 2 into z plus 1. So what will be P of z by z? You have to divide by z on both sides. We get 1 divided by z minus 2 into z plus 1. That can be written it as A by z minus 2 plus B divided by z plus 1. Then you multiply the entire expression by this denominator. So 1 equal to A into Z plus 1 plus B into Z minus 2. That is what we get when we multiply the entire expression by this denominator term. So in order to find the value of Z, what we do is we shall put z equal to minus 1. If I put z equal to minus 1, this term will be 0. 1 equal to b into minus 1 minus 2. So value of b will be what? Minus 3 here we will have. So value of b is minus 1 by 3. So similarly, put z equal to 2. If you put z equal to 2, 1 equal to a into 2 plus 1. Here if I put 2, it will be 0. So value of a will be plus 1 by 3 because 2 plus 1 is 3. 3a equal to 1. So a equal to 1 by 3. So substitute in this expression, what do we get? P of z divided by z equal to a value is 1 by 3 into 1 by z minus 2. B value is minus 1 by 3 into 1 by z plus 1. Now that is P of z by z. So what will be P of z from this? Work out along with me. It will be 1 by 3 into z by z minus 2 minus 1 by 3 into z by z plus 1. Now apply inverse z transform on that term. So inverse z transform of P of z equal to 1 by 3 into, what is the inverse z transform of this term? Inverse z transform of z by z minus 2 is minus 2 power n. What about the second term? Yeah, it is 2 power n. It is 2 power n minus 1 by 3 into, what about z plus 1? It is minus of minus 1. So it will be minus 1 power n. Am I correct?
Yes, ma'am.
Yes.
Yes,
Okay. So
ma'am.
we have found inverse z transform of P of z. Now take Q of z. Here it is Q of z. Q of z is z square minus 1 divided by z minus 2 into z plus 1. Let Q of z equal to z square minus 1 divided by z minus 2 into z plus 1. Z minus 2 into z plus 1. So this is equal to what? Again you can split this as a divided by z minus 2 plus b divided by z plus 1. Then, am I correct? No. First we have to find what is q of z by z. Then you have to split it. Okay, first find q of z by z. This is q of z. So what will be q of z divided by z? From z square minus 1. If you take z outside, what remains? Z minus 1 by z remains. So if you divide by z on both sides, what remains over in the numerator? Z minus 1 by z. From z square minus 1, if you take z outside, it will be 1 z minus 1 by z. Correct? And when you divide by z, this z get cancels. Divided by z minus 2 into z plus 1. Am I correct? Anybody any doubt in this step? I have divided by z on both sides. So in the numerator z square minus 1 is there. We can write that if you take z outside, z minus 1 by z remains. So z you can cancel out. Now this you can write it as a by z minus 2 plus b by z plus 1. Then multiply the entire expression by z minus 2 into z plus 1. So when you multiply over here, numerator and denominator get cancelled, z minus 1 by z remains. That is equal to a into. When you multiply over here, z minus 2 get cancelled, z plus 1 remains. Plus b into. When you multiply over here, z plus 1 get cancelled, z minus 2 remains. This is what it remains. Now, we shall put different values for z. First, we shall put z equal to 2. If I put z equal to 2, this term will become 0. But here also we need to do the substitution. It will be 2 minus half, that is equal to a into z is 2 plus 1. B will be 0. So it is 2 minus half. What is 2 minus half? It is 3 by 4. Correct? 3 by 4 or 3 by 2? It will be 3 by 2, correct?
3 by 2.
4 minus 1, 3, 3 by 2. That is equal to a into 2 plus 1 is 3. So what is the value of a? 3 get cancelled. It is half. Am I correct? Yes or no?
Yes, ma'am.
Okay. Next we shall put z equal to minus 1. If I put z equal to minus 1, coefficient of a will be 0. So put here also z equal to minus 1. Minus 1 minus z is minus 1, that is equal to a will be 0, b into minus 1 minus 2. So what do we get over here? Here minus 1, this minus 1 will be plus 1, correct? So plus 1 minus 1 will be 0, b value will be 0. Am I correct?
Yes, ma'am.
On the left hand side we will have 0, so it will b value will be 0. Let's substitute here in q of z by z. Q of z by z will be a is 1 by 2 into 1 by z minus 2. See here, substitute a. By a is half into 1 by z minus 2, b will be 0. So this term won't be there. So from this, what is q of z multiplied by z? Half times z by z minus 2. Now apply inverse Z transform. So inverse Z transform of Q of Z will be half times inverse Z transform of Z by Z minus 2. So what is this? Half times inverse Z transform of Z by Z minus 2 is 2 power n. Now let's take all these things together and substitute where is our main equation here. This is our main equation. We'll take this as star. Star is y bar of z equals y1 into p of z plus y0 into q of z. Correct? From star, y bar of z is what? y1 into p of z, y1 into p of z plus y0 into q of z. In order to find the solution, we shall apply the inverse Z transform. So that is nothing but y1 into inverse Z transform of p of z plus y0 into inverse Z transform of q of z. Inverse Z transform of y bar of z is yn. y1 into what is inverse Z transform of p of z? Here it is. Inverse Z transform of p of z is 1 by 3 into 2 power n minus 1 by 3 into minus 1 power n. 1 by 3 into 2 power n minus 1 by 3 into minus 1 power n. 1 by 3 into 2 power n minus 1 by 3 into minus 1 power n. Then we have inverse Z transform of q of z. What is it? Here it is. Plus half times 2 power n with y0. Anybody has any doubt or anybody has got any other answer than this? I asked you all to work out along with me. Anybody has got any other answer?
No, ma'am.
Okay. So what we do here is we shall take this as yn equal to, here you see this, you can take the coefficient of 2 power n and 2 power n. So what we will get? y1 divided by 3. Coefficient of 2 power n is y1 by 3 and here it is y0 by 2. So this is what? Coefficient of 2 power n. Then we have coefficient of minus 1 power n. So I can write it as, here it is y1. So it is minus y1 by 3 into minus 1 power n. So in simplifications we can write it as yn equal to c1 into 2 power n plus c2 into minus 1 power n, where what is c1? y1 by 3 plus y0 by 2 and c2 is minus y1 by 3. So this is the solution of the difference equation which is given. Is it okay everybody how to solve these questions, how to solve the difference equation? I have given additional examples also so that solving by the method of partial fractions will be quicker. You may not get like suppose you have some, we have discussed about Laplace transforms where you have in the denominator irreducible factors. Such kind of questions will not be asked. You will be asked such simple questions only where you have a linear factor in the denominator, so that you can solve this easily. So I've discussed additional questions. I really hope that solving difference equation is quite easier for you all by now, because I have discussed the questions and I have asked you all to work out along with me as well. So if you do that, it will be very easier for you all. Always remember that. If you work out along with me, it's always easier for you. Okay. Anybody has any doubt? If you have any doubt, you can contact me after the class. Okay? Done? Okay, let's meet in tomorrow's class. Thank you, everybody.
Thank you, ma'am.